Hi, I'm Benjamin Chavez, and for our ME 106 project, my teammates and I designed a Mechatronic hydraulic robotic arm, codenamed Martha 2.0. So what we used is a syringe network using water-filled vinyl clear tubing. We used 2 servo motors to lift up the arm and the object. We also used one more servo right here located in this aluminum base to rotate the object to whatever the user wants the object to be placed. And we also use the potentiometer, which controls the base. So as a demonstration, I'm going to place the bottle in the arm, and we're just going to close the jaws, and it's going to trip this little tactile switch that we have right here, and it'll lift up the arm. And using rotation on the potentiometer, we could place it to wherever the user likes.
Hi, I'm Albert Hernandez, and I'm going to talk about the fabrication process of this claw. To begin, I'm going to talk about the base and how we laser cut a 6.5-inch diameter piece of wood in the lab room, and then underneath it we actually attach the servo. We have to drill 4 holes in it and secure them with nuts and bolts, so it allows the arm to be more stable. And then for the columns, we have to wood glue them down here so they would stay really strong, not move. And then we have to put the servos up on top of them. As you can see, this gives them the motion to lift up the arm. And as you can see here, we had to drill some holes in there to secure them in place. The arm itself was made from white oak, and we picked it because of its high density. This was a 6-foot by 1 inch by 1/2 inch piece of wood that we actually cut out with the specifications from SolidWorks, as you can see here on the poster. And this is able to have this piece of wood be free in order to close the claw. And then we're going to talk about how we kept everything nice and neat with these. This is just a typical lunchbox where we put the potentiometers. As you can see, we have to drill a hole just big enough for it to fit, but not enough for it to go through it. And we have to drill more holes so we can have the cables out and yet be able to put everything in here so it could look nice.
Hi, my name is Ed Hoya, and I'll be talking to you about the Arduino schematic for our Mechatronic Arm. Here you can see all the electrical components of our system. We have the Arduino as a microcontroller controlling all the Mechatronic Arm. Here we have an external battery source for 2 of our servos for the lifting mechanism. When we connected it just to the Arduino itself, it wasn't getting enough power, so it didn't have enough torque to lift the arm. So we had the extra 6-volt battery, and we connected the servos to the 6-volt battery itself, and we have a 9-volt battery connecting to the Arduino so that we won't have to be connecting it to our computer at all times. Here we have all the pins connected to the breadboard. Each one of these pins, one is for the potentiometer, another one is for the limit switch, 3 are for the servos, and as you can see, everything is connected to one common ground. The tactical switch that we use, we connected it in normally closed. It has 2 different options. It's normally closed or normally open. We chose normally closed because when the switch is not triggered, it is reading 0 voltage, and so when the limit switch is triggered, it's active high. So you'll see an input as a 1. So in our program, we tell the arm when it is high to lift up the mechanism.
Alright, so from this project, what do you think you guys learned?
So one of the things we learned is time management. As you can see, this project took a lot of time to do. We had to change the design 3 times. We had to do some SolidWorks and specs before we could even get to building. And also the electrical components weren't easy, so we had to take a lot of time to figure out how everything worked together.
Yeah, I also think effective communication was also key to this project too. That allowed us to get everything done on time, as well with time management. Anything else you think?
Also, we learned how to apply the theory that we learned in our classrooms into making a project. We learned how to apply what we learned in our labs and how to control a servo with a potentiometer, how to use a limit switch to do something in your system. In addition to that, all the circuits that we learned in our labs, how to use the breadboard to design our electronics components, and basically what we learned in our fluids class, and how to control this mechatronic arm with using syringes. So it was just good to see all the theory that we learned in our classes being applied to this project.
Yeah, I think the overall Arduino program itself was a good source to learn, or good knowledge to have in our future.
And it was really fun to do.
Yeah, it was fun.